Yesterday we created Linux partitions as well as swap and swap file, something, right? So that is one method to manage storage device using fdisk tool. So once you created a partition with specific size, so when it required to extend the partition size from existing size to new size, so required a downtime. So before going to take downtime, first we have to take backup. Okay, see, then we have to delete existing partition, then create a new partition with new size. Again we have to restore the data. So that is the process when it required to extend. But with the help of logical volume manager, on fly, on demand, we can reduce any partition size, we can extend any partition size. Okay, so here we can combine two or more storage devices as a one logical volume, one volume group. So we have a physically 500 GB storage device and another one is 500 GB storage devices. You created some partitions here, but available space is 50 GB, and here 200 GB space is available on second storage device. So when it required to create a partition, once 100 GB, we can directly create on second storage device, right? Yes, we can create. So 100 GB. Once you created 100 GB, so still we have a 100 GB storage space. So there is another requirement to create a partition with 200 GB space or 150 GB example. 150 GB. Then, so how can we create 100 GB, 150 GB partition here? So if you want to store the application data into one particular storage, okay, we have to make partition, then we have to make file system, then we have to mount. So using that mount, we can access that particular storage partition. Then we can store application data into that. How to create? Here 50 GB is available and here 100 GB is available. Is it possible to create 150 GB storage partition? Physically, we can't combine. This is one physical storage device. This is one physical storage device. Physically, we can't combine two storage devices, but logically, we can combine. See, when like a 1 TB volume group, 500 plus 500. Physically, we can't combine, but logically, we can combine. So for that, we have to configure LVM, logical volume manager. Okay, to configure logical volume manager, first we have to create a LVM enabled partitions. So once you created LVM enabled partitions, convert those partitions into physical volumes. You have to create a physical volumes from that. Once you created physical volumes, then create a volume group, add those physical volumes into that group. Okay, so 500 GB, 500 GB. Now add those two physical volumes into volume group. From volume group, as per requirement, we can create logical volumes. How much space required for a specific storage purpose? We can create 100 GB partition, 150 GB, 50 GB. Okay, once you created a logical volumes, for example, you created 100 GB logical volume. So once you, after creating that, we have to make file system, same process, then create a mount point, mount it. Okay, see, the storage space almost full, 80 GB. So only free space is available, 2 GB. If you want to extend this 100 GB to 200 GB, yes, we can easily extend without taking downtime. Downtime not required here. Without data loss, we can extend simply. So here we have a LV extend command. Just using LV extend, we can extend existing partition size 100 GB to 200 GB, 150 GB as per requirement, without data loss also. Okay, without interrupting any work. If someone is working on that, so without interrupting, directly on fly, we can extend. See, so if you want to extend the partition size logically, so required a free space, right? at volume group. First we have to examine volume group. Is there any free space available? Then we can extend. If there is no free space available, then attach new physical devices into server, then create LVM enabled partition, then create physical volume, add this physical volume into volume group. Right? From that we can extend. We'll see now. Just note down LVM. Okay. LVM is a method of allocating hard drive space into logical volumes. LVM is a method of allocating hard drive space into logical volumes. Hard drive, yes, or storage device. Hard disk, you can note. Space into logical volumes that can be easily resized. As per requirement. And makes it easier to manage storage space. With LVM, set of storage devices or hard drives are converted into one or more physical volumes The physical volumes are combined into volume groups. Each volume group is divided into logical volumes which are assigned to mount points. Note down LVM features. It is flexible to expand. The storage space at any time. Okay, next. Any file system can be installed and handled. Next, migration can be used to recover Migration can be used to recover. Migration can be used to recover faulty disk without data loss. Faulty disk without data loss. Next, restore the file system using snapshot features to earlier stage. Restore the file system using snapshot features to earlier stage. Okay. Next, note down one small note point. While using logical volumes, we can extend across multiple disks. While using logical volumes, we can extend across multiple disks comma logical volumes or reduce logical volumes reduce logical volumes in size without reformatting and repartitioning. In size, reduce logical volumes in size without reformatting and repartitioning the current disk. Without reformatting and repartitioning the disk. First up, volumes can strip data across multiple disks. Volumes can strip data across multiple disks. Volumes can strips data across multiple disks. This can increase the IO stats. This can increase the IO stats. IO. That means input output operations, reading and writing. Right. So this is advantage. Next, note down. Logical volumes can be used in RAID, SAN. Logical volumes can be used in RAID, SAN. SAN in the sense storage area networks. Storage area networks. RAID, SAN. SAN, SAN. Right. Next, note down to configure LVM. To configure LVM. First, create LVM enabled partitions. Next, convert them as physical volumes. Okay. Create volume group and add physical volumes into that. Next, create logical and assign mount points. Volume to make file system and assign mount points. Right, so this is the process. Fine, now we'll see how to create, attach one more storage device. Attach it. If you want to attach another storage device. Right, so same process. First we have to examine how many storage devices are available. String of this -l, which was all storage device names. So SDA, SDB, SDC, and SDD. 4 storage devices attached to this machine, right? Fine. Now select this F disk. So yesterday we mounted some partitions, right? By default mounted or not? SDB1 is mounted on data, SDB2 mounted on backup, SDA1 is mounted on boot, something, right? Just mounted or not? Successfully mounted, right? See, because we added this file system information into fstab, permanent mount, right? So that's why even SPAP also by default is mounted. Okay. See, let me check the SPAP. SPAP size 2.8 GB. Yesterday we extended like this. If you pour on the machine, so automatically whatever the entries here automatically will be mounted on desired mount points. Now we have a SDC storage device and SDD also, right? And use fdisk /dev/SDC. Right, run. So M for help. If you want to see the existing commands here in this environment, to create new partition, that means to add new partition N. Okay, so select the default thing. So create a partition with available size as a single partition. We have a 8 GB storage device here, created a 8 GB storage partition. I'm not going to make any multiple partitions. Okay, just create it. So one partition as the entire storage device. If you want to see that, create it. Yes, Linux partition. Now we have to convert this Linux to Linux LVM. So how to convert? So we have a list of Xcodes. Just run HOS Xcode name numbers. Search for this 80E. 80 Linux LVM. Use that Xcode. To change partition type, we have a command toggle. Enter. See, by default here selected partition 1, right? So after this we have to enter partition name number. Here we have only one partition, that's why I selected. If you have more than one partition, it will ask which partition you want to change. Okay, now enter Xcode 80 Successfully created LVM enabled partition. Right. So repeat the same step on SDD. And created, convert T, enter X code 80 LVM. Created, yes, save and quit. Successfully we created LVM enabled partitions. Now run path to probe. Path probe. So without rebooting machine, we can update information to kernel. Successfully updated. Now we have to convert this physical as physical volumes. How to convert? We have a command pv create. pv create. pv create device names sdc1 /dev /sdd1. At SDC storage device, we created one partition, and SDD created one partition. Right? When you run this successfully, these volumes will be converted as physical volumes. Okay. See, like we can specify individually each storage device name. So instead of this, we can use wildcard character, right? C to D or C comma D. You can specify or not? Yes. Individually you can specify or use wildcard characters. We can specify this way. Say successfully created here physical volumes, right? Now I have two physical volumes. Run pv display command to see the existing physical volumes information. pv display. It shows all physical volumes, names, and the structure, the size. Okay. So if you want to see a specific physical volume information, /dev /sdc1 example, it shows only that particular physical volume information. pv create is the command to create physical volumes. pv display to view or see the existing physical volumes information. Right. So we have a pvs also. It shows detailed information about physical volumes. pvs. How many physical volumes are available? See, first field is pv. pv means physical volumes. sda2, sdc1, sdd1, and this is volume group name. Volume group. So here we have an existing volume group CL. Okay, and this is format type LVM2, and this is physical volume size, total size, and available free size. Available free size. Right? When you run pvs, pv display, it shows only detailed information about physical volume, each physical volume. So if you want to see physical volumes added into which volume group, so available size, all these things, just run pvs. Right? See, these two are we created, right? Physical volumes, but these two physical volumes are not added into any volume group. Right? Now create a volume group. Create a volume group. vg create volume group, add physical volumes into volume group. vg create, then volume group name. You can specify any name here. Here just specified vg1 volume group name. Volume group name, then physical volumes name. Which physical volumes you want to be add? Which physical volumes you want to be add? /dev /sdc1. The same thing here we can specify, right? C2D1 /dev /sdc1 /dev /sdc1. See, volume group VG1 successfully created. Volume group VG1 successfully created. VG display. VG display. Once you run VG display command, it shows all volume groups information. Volume group name and volume group total size. What is the size it shows here? Volume group size 16 GB. To physical volumes, with each 8 GB added into this volume group. Now total size is available 16 GB. Yeah, we can combine it here. So active physical volumes 2, current physical volumes 2 in this volume group VG1. So if you want to see a specific volume group information, just specify VG display space VG1, or we have existing, right, CL volume group. So it shows volume group size 7 GB. So only current physical volume active. Added only one physical volume into that. We can add one or more physical volumes into one volume group. So this is one existing one, CL. See which one? So here created some partition with a specific size for boot, and some space is utilized for other purpose. The remaining space is created as a physical volume. The space is added to volume group. From that created a root partition. See, so during the installation process, when you select or when you choose automatically create partitioning, by default partitions will be created with LVM. Okay. See, to install operating system, so boot partition we have to create a normal traditional Linux partition. Remaining partitions we can create with LVM enabled. Okay, if you created a boot partition with LVM enabled, system won't boot up. Okay, for that we have to create a one Linux partition, standard partition, right?
If you create manually,
yeah, we can create manually. Manually also it shows, right, standard partition, LVM thin provisioning. Just select the LVM or LVM thin provisioning. Okay, partitions will be created, or just create a Linux partitions. So we can convert during the installation process. Okay, real time recommended to create LVM enabled partitions when you install a operating system on any storage device. Okay, so we can easily manage. If not created with LVM enabled, it's very difficult to manage. So when it requires to extend the storage partition from one size to another size, so even we can't reduce. Okay, successfully we created volume group. So we have VGS also. Just run VGS. It shows volume groups information, volume group name, and physical volumes into that. How many logical volumes created on each volume group. The third one. Okay, so these are all attributes. We'll see this later. And this is volume group size, and this is free size. Volume group free size. Right, VG1. The total size is 15.99 GB. Available size is 15.99 GB. Because there is no logical partitions created on it. Now create a logical volumes. LV create to create logical volumes. Hyphen capital L size. We have to specify size. 1 GB. 1 GB. From which volume group you want to create this logical volume? Specify the volume group name. Volume group name we have to specify /dev/VG1, or directly we can specify VG1. Once you created a volume group, that is also a logical device, right? All devices information stored at dev directory. The path is /dev/VG1. Right. From this volume group, create a logical volume. Specify the name of the logical volume, -n name, LV1 Here I am specifying logical volume name. Run. Logical volume LV1 successfully created. LV display to see the existing logical volumes information. Okay, and if you want to see the specific logical volume information, LV display LV1. Sorry. So here we have to specify complete path /dev/vg1/lv1. This is a path, logical volume path. So logical volume created under volume group. So volume group is under dev volume group name and logical volume name. So if you want to see that path, LV display, it shows logical volume path, right? Logical volume name, volume group name, logical volume UUID, permissions, read write, logical volume size. Correct? LV display or run LVS, which shows detailed information, logical volume name, volume group, attributes, LVM size, and the same utilization in percentage. Everything it shows LVS. Successfully we created. Now run PVS after creating logical volume. See the size. This two physical volumes added into volume group VG1. We created 1 GB partition selected from SDC storage device space. Number of blocks selected from 1 GB blocks from SDC storage device. Right. Now run VGS. What it shows? Available 1 logical volume and total size, available size, volume group size. We can see, right? Right. So create another logical volume. LV2 with 3 GB size. With 3 GB size. Created. Run PVS. See. SDC1. Selected from SDC1. Now create a 6 GB partition. What will happen? See. PVS. Selected from which storage device? SDD1. SDD1. Now try to create 5 GB partition. 5 GB. Run PVS. See basically here available 4 GB. Selected 4 GB blocks. The remaining blocks 1 GB selected from SDD1. Is that is possible in physical environment? No. Logically, automatically selected some blocks from another storage device, which is added into volume group. Okay. So when you create a partition, automatically it allocates some blocks from either first storage device or second storage, any other storage devices. Pardon? Yes. Here we have only 1 GB available free space in the volume group VG1. If you want to create a 10 GB partition, we can't create. So for that, we have to add another storage device into the server, convert that into physical volume, add physical volume into volume group, from volume group create a partition log. Okay, right. After creating logical volumes, we have to make file system, MKFS. ext4 or xfs slash dev slash vg1 slash lv1 mkfs.ext4. Just listen. Concentrate on board. mkfs.ext4. See here, making file system on newly created logical volumes. Just we have to specify logical volume path slash dev slash vg1. What is vg1? Volume group name. So if you want to make file system on, the partition is created under cl volume group. We have existing cl, right? Slash dev slash cl logical volume name we have to specify. Created. Yes, we have another one. lv2. So if you want to make another file system on that xfs, you can. Created. Now make mount points lv1. Example here I'm creating. Okay, simple names lv1, lv2. See, use mount slash dev volume group name, then logical volume name slash lv1. Successfully mounted. Mount the second one also. So this is logical volume name and this is mount point name. Now run df-h. Mounted. Mounted on lv1. See, 1 GB and this is 3 GB. That's it. To make it permanent, this mount point, add into fs tab. So you can add the path like this or like this. Both are same. Both are same. You can add like this or like this into fs tab entry as a file system name. See, eim/etc fs tab. Sorry. Slash dev slash mapper or then vg1 hyphen lv1. Like we can specify or directly we can specify like this. Right, the same thing. Mount point name slash lv1 file system ext4 defaults 0 0. Right, repeat the same step for all partitions. Right, this is how to create a logical volumes. How to create a volume group, how to add. Now we'll see how to extend and how to reduce logical volumes and volume groups. Okay, extending the size. Yes, not hard disk. We have a partition 3 GB, right? To increase the size of partition 3 GB to 4 GB, 3 to 5 GB. Okay, yes, storage partition extension. See, now run pvs, have a volume group 1 GB we have available, right? We have existing one 1 GB partition, the first one lv1, right? Logical volume 1 is created with 1 GB size. Is it correct or not? lv1 1 GB. Now extend this 1 GB to 1.5 GB. Add 500 MB storage space into this without taking downtime. So before going to extend, just create a file into that. We'll see that later what will happen. Access this mount point, create file 1, hello lv1. It contains some data. Already partition mounted, right? Mounted. Here I'm not going to unmount. On fly, I'm going to extend. So before going to extend, just examine available storage space at volume group VG1. So we have 1 GB, right? So now extend your logical volume LV1. So we have a LV extend hyphen capital L plus 500 M. I'm going to extend logical volume name VG1 slash LV1. No need to specify any volume group name because the logical volume is already in volume group VG1. From this volume group only space will be selected. Size of logical volume VG1 LV1 changed from 1 GB to 1.49. That means 1.5 GB. Successfully extended or not? Resized, all right? Resized. Now we have to grow the file system. Here extended storage partition, but we are not extended any file system. See, existing file system size is 1 GB. Is it correct? So I have 1 GB partition. Say on this there is a file system like ext4 up to 1 GB. We created a file system. After extending this to 1.5 GB, still we have a 1 GB up to 1 GB storage blocks created as a file system. So remaining 500 MB, if you want to utilize, you have to make file system, right? So how to grow the file system here? If you make file system mkfs using mkfs command, existing data will be lost. So without making file system, we can increase the file system. That means resize. We can resize file system. So for that, depends on your file system type. We have a commands resize to fs for ext type file system. Resize to fs. For xfs file system, xfs underscore grow fs. To grow the file system. xfs underscore grow fs. So this is for ext type, resize to fs, right? If not extended, I mean resized file system, only up to 1 GB we can store data, up to 1 GB, even though if you have 1.5 GB. Resize. What is the file system on LV1? So if you want to check, just use df-h, right? Shows only that particular partition. What is the file system on that? ext4. So ext4, for that we have to use resize to fs. /dev /vg1 /lv1. Successfully resized. Now it contains blocks. Extended. That's it. Is it required any downtime here? No, right? Not interrupted. Let me check the information. We created one file, right? Yes, still data available. Read. Hello, LV1. Like we can extend. That means we can resize any logical partition on demand, on fly.
In this one, we need to unmount and mount it.
Which one? Yes. Normal traditional Linux partition, if you want to extend like this, so required downtime. So you have to unmount. Okay. So first delete the existing size. create it with new size. Create with new size. So before going to unmount, first we have to take backup for safety. Okay. Here not required. Like we can extend logical volume. Now we'll see how to extend volume group. Volume group. So that means how to add physical volumes into existing volume group. So we can create a new volume group. We can add physical volumes into that. So already we have a volume group VG1. If you want to extend the size, extending size in the sense adding new physical volumes into that. Okay. So for that we have to attach another storage device. Then we have to make LVM enabled partition. So after that, convert that into physical volume, add physical volume into existing volume group. Okay. fdisk -l. So here we have only SDD up to right. There is no additional storage partitions. Shut down the machine, add new storage, and we'll see how to extend. See, right click, storage. Here we have to select the second option. When you click on this class to add storage device. Once you add it, power on the machine. Right. Now run fdisk -l. See, when you run this, it shows the detailed information, and we have to scroll up and scroll down to see. We have a lsblk command. List block devices. It shows list of block devices. Block device name, under block device, the partitions available. Detailed information it shows. See, SDE, we have another storage device with 8 GB. See, SDD, we created some partitions. It shows same thing, right? Logical and SDC. Fine. LSBLK, list block devices information. fdisk space /dev/sde and the next partition created. Now convert this into Linux LVM. Enter 80 export for LVM. Converted. Run Path Pro. Now run pv create /dev/sde1. Right, run pvs. So available one physical volume SDE1, not added into any existing volume. So when you install Linux operating system with LVM enabled partitions, so if you want to extend your root partition, here we have a 7 GB root partition. There is no free space on SDA2. Complete storage space is allocated to root partition, SDA storage device. So these partitions we created, this system created physical volume, right? If you want to extend your root partition, then first we have to examine the partition is available at which volume group. Okay, if there is a free space available in the volume group, we can extend that root partition. If there is no free space available, here we have a available physical volume. Add physical volume into that volume group. Then extend partition, right? Now add this physical volume into volume group VG1. That means extending VG extend to extend volume group. Right, hyphen, sorry, VG extend volume group name, then physical volume name /dev /SDE1. Volume group VG1 successfully extended. VG extend space, volume group name and physical volume name. VG, now run PVS, added successfully into that, yes, volume group VG1. Now run VGS. Now it shows 8.5 GB available. So before it's available only 500 MB. Now we added new physical volume into volume group VG1. That's why it shows total size 8.5 GB. But the total size is volume group size 24. Available 8.5 GB. Okay. So here available 3 physical volumes and 4 logical volumes. Now create. This is how to extend volume group. How to extend. Now we'll see how to reduce logical volume and volume group. Logical volume. To reduce logical volume, so we have a LV reduce command. LV reduce. Using LV reduce, we can directly reduce any logical partition. But once you reduce logical partition with LV reduce command directly, what will happen? The data will be corrupted. Again, we have to make file system. Even though you reduce the size, existing volume, logical volume, we have to make file system. Once you make file system, data will be lost. So before going to that, first we have to resize the file system. That means reduce the file system from specific size to low size. Example, we have a 3 GB partition. If you want to reduce this size, that means amount of storage space. If you want to shrink from this volume, say 3 GB, so required 500 MB for another partition to extend. There is no free space available on your volume group. See, we can see available space at any logical volume. Okay, see, then we can reduce from that. So once you shrink that, the same space will be allocated to volume group. So from volume group, we can add that into any other logical volumes. See, here we have a 3 GB. If you want to reduce this 3 GB partition to 2 GB, we can with LVM. But here, before going to reduce 3 GB partition into 2 GB, first we have to resize the file system. Resize the file system. That means first reduce the file system 3 GB to 2 GB. Then shrink 1 GB space from that 3 GB partition. Without data loss, we can reduce. But here required a downtime. First we have to unmount. We have to unmount the partition. Right. Here we have LVS. Okay. Select this one. 5 GB. So reduce this 5 GB to 3 GB. Reduce this 5 GB to 3 GB. First, okay, not mounted, right? Okay, this one is mounted. Okay, take this or this one. These two are mounted. just unmount LV2, not mounted. Okay, so we are not created, I mean, information into FS tab, right? It's not mounted automatically. Okay, right. See, now reduce the size. First we have to reduce the file system, so that is depends on file system on that. So here we have a command. So resize TFS for ext type, xfs underscore grow fs for xfs file system. So one thing is xfs file system we can't reduce. We can't reduce xfs file system. Only we can grow. We can grow xfs file system. We can't reduce. So ext file type file system we can grow and reduce. We can grow and reduce ext type, either ext2 or ext3 or ext4. ext2 or ext3 or ext4, any type, right? The same command, resize to fs, using resize to fs command. Right. Fine. Run resize TFS. Before going to run resize TFS, we have to run file system read errors command to check. FSCK we have, E2 FSCK also we have. Once you run command, it checks all read errors. Is there any read errors at file system? It shows that information. So before going to reduce, right? So run E2 FSCK, E2 FSCK or FSCK command. Pardon? File system errors. Hyphen FF. So then logical volume name /def /vg1 /lv1. Select this. So LV2 is a we created file system XFS on that, so we can't reduce directly. See, LV1, there is no read errors here. Okay, there is no read errors. So now run resize TFS. Resize TFS. Resize TFS. Then /def /vg1 /lv1 space 1 GB. Reducing file system from 1.5 GB to 1 GB. Reducing file system 1.5 GB to 1 GB. See, resizing the file system on LV1. The file system is now right. So now run LV reduce command. LV reduce. Then -L -500 MB. That's shrinking 500 MB, right? From 1.5 GB partition, that's shrinking only 500 MB storage space. Reducing LV reduce -L -500 M space /def vg1 /lv1. Yes. Size of logical volume changed 1.49 GB to 1 GB. Successfully changed or not? Right? Successfully we shrink 500 MB storage space from existing logical volume. The same space is attached to volume group. Now run VGS. What it shows? Before it shows 8.5. Now it shows 9 GB. Free space. Before it shows 8.49, right? Now it shows 8.99. means approximately 9 GB. Successfully added, right? To reduce logical volume, first unmount the partition, run e2fsck command 4 to check file system read errors. Then run resize to fs space logical volume name space size to reduce right, correct. Then lv reduce F1 capital L size to shrink that means minus, you need to use minus size to shrink. Then volume group name logical volume name. Got it? So after this, so again run the e2fsck command to check for file system read errors. Run e2fsck -ff, then logical volume name that means rechecking the file system read errors. So then mount logical volume name space mount point name. That's it. Got it? Right. LVS. What is your size? 1 GB. 1.5 to 1 GB. Say 500 MB. Shrink it from that. Right. Mount it now. Mount /dev /vg1 lv1 /lv1. Let me check the data under. Yes, still we have file 1. Okay. See, before going to reduce the logical volume size, first we have to examine so how much free space is available. So based on free space, we have to specify the amount of storage space you want to shrink from that. If you specified, say as an example, we have a partition with 50 GB. Okay, their available space is only 20 GB. By mistake, you reduced the size, file system size 50 GB to, instead of reducing 30 GB, you reduce it to 25 GB or 20 GB. Okay, so free space is available 20 GB. So if you want to shrink amount of storage space from this up to 20 GB, we can shrink because the 20 GB free blocks available. But you reduce it, instead of reducing this to 30 GB file system. What will happen? Existing data will be lost. This means file system will be corrupted. So before going to reduce the file system or a partition size, first we have to check the size, available free space. From that available spaces, how much space you want to shrink, then specify the size. So based on that, file system will be reduced. We can shrink from that amount of storage space without data loss, right? So, but recommended while reducing the partition, take backup. You have to take backups, the data, whatever the data under, okay, for future reference. If something went wrong while reducing, we can restore it. We can create a new partition with new size. We can restore the data. Okay.
Same for backup, PGP.
Yes. Right. So this is how to extend and reduce logical volume. Now, how to reduce volume group? So reducing volume group in the sense removing one physical volume from that. Okay. For that, VG reduce, we have a command, VG reduce. VG reduce. Using VG reduce, we can reduce volume group. VG reduce, volume group name, space, physical volume name. Physical volume name. Which physical volume you want to be removed? You want to be removed from volume. That name we have to specify. See, so before going to remove physical volume, first we have to examine, is there any partitions created on? Is there any partitions created on? If partitions available on, just remove the partitions. The partition is not required, just remove. Have to remove. That means removing logical volumes. So before going to remove any physical volume, first we have to examine, is there any existing partitions on that? Okay, so for that we have to run command PVS or VGS, which shows, right, the partition created on this, or LVS, how many partitions are there. Okay, remove, then remove physical volume from volume group to reduce volume group size. To reduce volume group size. See, this is the syntax to reduce. Now we'll see how to remove logical volumes. For that we have a LV remove command. LV remove. LV remove logical volume name. That means the path we have to specify. To remove logical volumes. To remove logical volumes, LV remove logical volume path. Means example /dev /vg1 logical volume name. Example 4. I'm going to remove. Asking, yes, logical volume LV4 successfully removed. Run LVS. Remove, right? Remove LV3 also. Removed or not? Like that means, so before going to remove, we have to unmount. We are not mounted LV3 and LV4. That's why directly removed here. So before going to remove any logical partition, okay, it is better to take backup first, whatever the data under for future reference, then unmount and remove the command. So remove the partitions using LV remove. Like we can remove. If you want to remove volume group, we have a VG remove. VG remove. So note down, to remove volume groups. To remove volume group, VG remove volume group name. Volume group. So volume group name example, if you want to remove VG1 volume group /dev /VG1. Volume group name, right? Example. VG remove. Got it? So before going to remove volume group, first we have to check the logical volumes and is there any data. So first we have to take backup, then remove the logical volumes, then remove physical volumes from this. That means reduce the volume group. Then execute vg remove command to remove. Okay, right. Next, to remove physical volumes, pv remove physical volumes names, physical volume names, that means partition names. pv remove space partitions or physical volumes. Right. First tf hyphen th. So here we have the LV1 is mounted on LV1, right? So unmount umount slash LV1 unmounted. Okay, so there is no mounted file system now on VG1 volume group. Okay, we have a partitions like this. First remove these partitions. LV remove slash dev slash VG1 slash LV1. Sorry, removed. See now, VGS complete space is available. Okay, VG remove volume group name slash dev slash VG1. VG1 successfully removed. Volume group removed, right? Now remove physical volumes. PV remove slash dev slash SD C2E1. Labels on physical volume successfully wiped. To delete logical volume, use fdisk device name, then delete. D is the command. Or to convert that into normal traditional Linux partition, yes, we can convert. Just run T, enter, put is the export for Linux partition 83. That's it. Right. So this is how to create a logical volumes and how to extend, how to reduce logical volumes and volume groups, and how to remove logical volumes, volume groups and physical volumes. Okay, now we'll see how to create snapshots, how to create and restore snapshot. So note down snapshot. Snapshot is nothing but a restore point of existing volume. Restore point. Yes. Existing volume, logical volume. Next, note down. If we have accidentally deleted any files after creating a snapshot, if we have accidentally deleted any files after creating a snapshot, We don't have to worry. So we can restore. So if we have accidentally deleted any files after creating a snapshot, so we can restore those files. With snapshot. Fine. See how to creating snapshots. We'll see. So first to make again physical volumes. pv created physical volumes. vg create volume group name /dev/sd created, successfully added all these three physical volumes in this. Now create lb create hyphen capital L plus 1g, then volume group name /dev/vg1, or directly you can specify vg1 hyphen m lv1. Okay, we are not updated, right? See, successfully created lv1 make file system mkfs.ext4 /dev/vg1 lv1 successfully created file system on lv1 logical volume. Now mount this. Already we have a mount point name lv1. Yes, mount it. Successfully mounted. Yes, mounted, right? Now create some files into this. cat/lv1 so it contains one file. Just we created. It contains now two files, file 1 and file 2. File 1 and file 2. Now create a snapshot for this. Snapshot. Note down. lv creating snapshot. Hyphen capital L. Snapshot size we have to specify. So we can create a snapshot with same size, volume size, or we can create with specific size, with lesser size. Okay, so that is depends on 500 m space hyphen s. S stands for create snapshot. Hyphen n snapshot name lv1 underscore snap. Then for which logical volume you want to create snapshot, that logical volume path you have to specify. lv1 right, that's it. So automatically snapshot will be created under volume group vg1 with 500 MB. Logical volume lv1 underscore snap is created. lvs lv1 underscore snap vg1 something it shows, right? Now access this drive. So create another file, file 3. Just added one thing. Now it contains some files. So remove one file. Okay. Then we'll see how to restore snapshot. Once you restore snapshot, is the data will be restored or not? We'll see. Just remove file 2. File 2 removed accidentally. We have a snapshot, right? We can restore. Note down. Restoring snapshot. Restoring snapshot or merging. Restoring snapshot or merging. Note down. So, to restore the snapshot, unmount the file system first. Unmount the file system first. You mount this one, or you can LV1 directly mount point name. Unmounted. Okay. So df-th. Yes, unmounted. So next, run lv convert. lv convert space hyphen merge /dev /vg1 /lv1 underscore snapshot name we have to specify. Snapshot volume is created under vg1 volume group, right? The path we have to specify like this: lv convert space hyphen merge /dev /vg1 /lv1 underscore snap. Note down, note point. After merging snapshot, that means after merge completed, snapshot volume will be removed automatically. After snapshot merge, snapshot volume will be removed automatically. Successfully merged, right? 100%. Now mount /dev /vg1 /lv1 got it. File 2 we restored, right? Just read the data lv1 and file 2 data we got, right? See, this one we can calculate with we have a du here. Taken one small example. If some data loss like 1 GB, 2 GB, 3 GB, so before going to merge, if you want to see that size, so we can see that, right, with df-th. When you run this, it shows volume and its total size, used size and available size. It shows, right? So after merging, used size, available size, we can see the differences. Okay, we can see the differences. See, we can extend snapshots also. We can extend same. Pardon? File 3 is not merged. Okay. Where it is? See, after creating snapshot also need to merge that, but why it is not taking? So after creating snapshot, whatever the files is under the volume, those files will be restored. So before creating snapshots, is there any files got removed? We can't restore. Yeah, file 2 restored. File 3. Yeah, we created file 3 also, right? No, so it takes that information. The same everything, whatever the files you created after creating snapshot, the same information will be synchronized to snapshot volume, synchronized automatically. Okay. Okay, note down what another note point. To extend snapshot, use lv extend command. Use lv extend. This is manual process. To extend snapshot automatically. To extend snapshot automatically. Edit /etc lvm/lvm.conf. Edit /etc/lvm/lvm.configuration file. Then search for the word auto extend. Then search for the word auto extend. Auto extend. Search for auto extend. See what it shows. Percentage, and it shows here the value. Another one, threshold value, right? tin_pool auto extend threshold 100. The one is okay. Search for the word. Okay. See, basically it shows the name like snapshot _ auto extend _ threshold, the parameter. Note down that. Or now it shows in the new version like this, tin_pool. Okay. See, okay, sorry, here that names snapshot _ auto extend, this one. Search for this parameter, snapshot _ auto extend _ threshold, and snapshot _ auto extend _ percentage. If you want to note down the line numbers, you can note down. (1383) and 1396. Snapshot _ auto extend _ threshold. See, threshold value in the sense, if you have a snapshot size, so logical volume size 5 GB, and you created a snapshot with 3 GB or 1 GB. So after creating snapshot, when you store data into this 5 GB storage partition, so automatically the size also increased. Okay. So see, when you store 1 GB data, so automatically 1 GB snapshot will be synchronized, the same with same data. Okay. So when you store more than 1 GB, so data will be overflow. Once data overflow, automatically snapshot will be removed. Once data get overflow, automatically snapshot will be removed. See, for that we have to every day examine. So we have to extend the size based on this requirement. So instead of that, we can extend this snapshot size automatically on demand. Okay, when you write data into this, based on this, when it requires more space to synchronize the same information, automatically we can extend. So for that, we have to specify a threshold value. When amount of snapshot storage space is reached to 80%, sorry, 80% or 70%, extend the size in 20%. Extend the size in 20%. 20% in the sense 1 GB, 200 MB automatically extended. That means 1.2 GB. So when it reaches 2 in 1.2 GB, 80%, automatically again 20% will be increased. Automatically 20% will be increased. That's why we have to specify the threshold value here, and auto extend percentage, amount of storage space need to extend after reaching to threshold value, right? 70 or 80 specify, then specify the amount of storage space to extend in percentage. Got it? This is how to create snapshots. Okay. Fine. And people need to remember, so we can't reduce XFS file system. I think last month, so some guy faced the same interview question. One guy. Okay. So is it possible to reduce XFS file system? No, we can't reduce. Only we can grow XFS. XFS underscore grow FS. So for ext type, resize to FS. Resize to FS. We can increase, that means we can extend, and we can reduce file system size. To take backups, ext4, ext type file system, the command. So XFS file system, XFS dump. To restore ext type file system, restore is the command. That means after taking the dump file, if you want to restore dump file, use restore command. So XFS file system, use XFS dump, create a dump file. So if you want to restore that, we have XFS restore. XFS restore command. So this is all about right. So note down one small note point. To check for the FS tab entry syntax errors. To check for the FS tab. FS tab means file system table /etc/FS tab. /etc/FS tab. Entry errors. Errors, just run mount space -av or a, that's it. Mount space -av. Fine.